A force is that cause which can produce motion in stationary body, can stop a moving body, can change the direction of a moving body, or it can change the shape and size of the body. But now the question is, how do we calculate the magnitude of the force? The answer is in Newton's second law of motion. In this video, I am going to talk about the derivation of the formula F is equal to ma based on Newton's second law of motion. The second law of motion states that the rate of change of momentum is directly proportional to the force applied, and the change in the momentum takes place in the direction of the force applied. So if we convert this statement into the mathematical formula, we can say that rate of change of momentum, that is delta P upon delta T, is directly proportional to the force applied. Now if we remove the proportionality sign here, we have to write the equality sign and write some constant. So I am writing K as a constant here. So delta P upon delta T is equal to Kf. But the unit of force here is chosen such that the value of K becomes 1. So what we can conclude from here is that delta P upon delta T is equal to F. Let us say this is our equation number 1. Now consider an object of mass m moving with some initial velocity u. Now since this object is moving with some initial velocity u, we can calculate its initial momentum. So initial momentum is Pi, that is mass times velocity, mu. Now consider that a force is applied. Okay, if we want to change the velocity of the object, a force is needed. So consider that the force is applied on this particular mass for time t, due to which the speed of the object changes from u to v. And consider that v is the final velocity after time t. So once we get the final velocity v, we can find out what is the final momentum. So final momentum is Pf, that is mass times velocity. Now from these two quantities, that is initial momentum and final momentum, we can calculate what is change in the momentum. So let us say change in momentum is delta P, that is mv minus mu. Now I am going to substitute this value of delta P in equation number 1. So what do we get here is mv minus mu upon delta T is equal to F. Instead of delta T, we can write T minus 0. So this equation becomes mv minus mu upon T minus 0 is equal to F. Taking mass common and rearranging, we get m times v minus u upon T is equal to F. But we know that v minus u upon T, that is change in velocity per unit time, is acceleration. So we can say ma is equal to F. On rearranging this, we get F is equal to ma. This is the most important equation in mechanics. This equation relates the force to the measurable quantities like mass and acceleration.